233 million years ago, the supercontinent of Pangaea was a massive, stable, and incredibly hostile desert. The interior of the landmass was bone dry, baked by extreme heat and locked in a state of deep aridity. While the very first dinosaurs existed in this environment, they were small, rare, and entirely outmatched. The landscape belonged to giant, heavy-set reptilian herbivores like Dicynodonts and Rhynchosaurs, which monopolized the sparse vegetation. Because these massive reptiles consumed nearly all the available resources, the early dinosaurs were trapped at the bottom of the food chain. Under these dry, stable conditions, they had no clear path to dominance. Then, the skies finally broke. The global desert was suddenly subjected to a violent monsoon downpour, instantly transforming the red dirt into a rushing river of mud and debris. This wasn't a seasonal shift. The rain fell continuously for over 1 million years. It overwhelmed the global climate system, replacing the dry heat with a sweltering and relentlessly humid hothouse. Geologists call this prolonged weather anomaly the Carnian Pluvial episode. The word pluvial simply refers to a period of abundant rainfall. 1 million years of rain drowned the drought-resistant flora of Pangaea. The specialized plants rotted away, and the giant herbivores that relied exclusively on them quickly starved to death. To find the trigger for this endless storm, we have to look to the bottom of the ancient Panthalasan Ocean, at a geological formation known as the Wrangellia Large Igneous Province, a massive accumulation of rock formed by extreme magma extrusion. For millennia, the ocean floor tore open. Millions of cubic kilometers of flood basalts poured out from the crust in a continuous, violent eruption. The magma itself stayed primarily underwater, but the intense heat baked the surrounding oceanic rocks. This reaction released staggering quantities of carbon dioxide directly into the atmosphere. This is proven by the chemical signature in the rock record. Researchers identified a negative carbon isotope excursion, a severe drop in heavy carbon atoms. The dates for this atmospheric carbon spike align exactly with the Wrangellia basalt's eruption. The lava did not reach the animals on land. The lethal blow to Pangaea's ecosystems was the rapid chemical change in the air itself. Here is the direct result of that carbon injection. Global average temperatures spiked rapidly, rising 3 to 8 degrees Celsius. This trapped heat drastically accelerated the evaporation of the Panthalasan Ocean, lifting millions of tons of water vapor into the air. The vast temperature difference between the boiling oceans and the interior of Pangaea created an extreme atmospheric pressure gradient. This dynamic drove relentless, hypercharged monsoons deep into the once arid continent. The oceans suffered too. Carbon dioxide dissolved, the seas acidified, microbial ecosystems died, carbonate platforms collapsed. This mechanistic chain reaction, from magma to carbon to heat to rain, effectively removed the giant reptiles that had dominated the continent for millions of years. Eventually, the Wrangellia eruptions stopped. The atmospheric carbon was slowly reabsorbed, the temperatures cooled, and the long rain ended. The red desert was gone for good. In its place stood dense, humid conifer forests that produced massive amounts of tree resin, which we now find preserved globally as fossilized amber. The giant, specialized reptiles that ruled the dry Pangaea could not survive the transition. Their extinction left vast biological niches completely empty. Surviving this climate shock was a test of adaptability. The species that made it were those that could find food in a rapidly shifting landscape, where size and strength offered no protection. Those small, marginalized dinosaurs from the deep desert were perfectly equipped to step into this empty world. Because they evolved at the bottom of the food chain, they were already nimble, highly adaptable, and accustomed to surviving on sparse, unpredictable resources. Other lineages capitalized on the empty space as well. This period saw the first turtles, the first crocodiles, early mammals, and modern scleractinian corals, the hard skeleton organisms that build today's reefs. If you were standing in those new conifer forests, you would not hear the open-mouthed roars typical of movie monsters. Research on modern birds and crocodiles indicates these early dinosaurs likely communicated with closed mouths, producing a deep, vibrating coo. The dinosaurs did not conquer the Earth by defeating the old guard. They simply held on while the Earth tore itself apart, and when the rain finally stopped, they were the only ones left to inherit the planet.